Okay, 8.4, trigonometry, right triangle trig, in fact. There's different kinds of trig. There's a circle trigonometry, but we're going to be dealing with right triangle trig. And who knew that so much trigonometry was involved in fishing? So next time you go out fishing, you can think of all the math that's involved in that event. Okay, so here's your tip of the day, basically. Sokotoa, where the wind comes rolling down the plains, or whatever the words are. I should make up my geometry words, right? Sokotoa, you need to know how to spell that. So if you think you have a little trouble spelling, get that down because it's going to save you as far as any of the geometry we do. Okay, sine. You have a button on your calculator. It looks like sin. Don't say sin. Don't go off to college and say, I'm going to touch the sin button. Then they're going to be like, where did you go to school? You might get some of those looks, and nobody wants those looks. So you say sine. They just abbreviated it S-I-N because they can fit it on the calculator there. Cosine and tangent. Sine is opposite over hypotenuse. Sine is the S. O is opposite. H is hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so how do we figure out what is opposite, what's adjacent, what's hypotenuse? Well, hypotenuse should be set in stone, so let's go ahead and look. I didn't mark it in here, but every single one of these is a right triangle. So this is right triangle trig. Okay, we're just gonna, I feel like I gotta do it right here. Get my right angles in there. Okie dokie, so here's what we got. If this is 31 degrees, this side is opposite. This side is adjacent. And this, of course, is hypotenuse no matter what. So, if I'm going to do any of these, let's just start with sine here. And if you recall, sine is opposite. It's sokotoa, so opposite over hypotenuse. See how I abbreviate that? Opposite over hypotenuse. So 31 degrees, because we're taking this angle here. Opposite is 3. Hypotenuse is unknown. Okay, I guess I'm just going to put x, just so we can write it out. Now let's take the cosine. Cosine of 31 degrees is, so kotoa is adjacent over hypotenuse. So the adjacent is this side right here. Adjacent means next to. See how this comes right into 31? You're like, well, what about this one comes right into that? That's your hypotenuse. It's automatically the hypotenuse right from the get-go. You can't change that. So the other one that's coming into the angle is going to be your adjacent. So I'm going to take the adjacent number, which is 15, and then my hypotenuse is, I'm going to put it x again. Tangent of 31 degrees. So tangent of 31 degrees, I'm sorry I didn't write, I did, is going to be opposite over adjacent. Toa, T-O-A. Tangent, opposite over adjacent. All right, so I'm going to take my opposite. Notice how this side is way on the opposite side from that angle. So we have 6 over the adjacent, which is 10. Okay? And then sometimes you work it out. Maybe you have a tangent. I'm just going to do tangent example here. 31 degrees, opposite over adjacent. Okay, and then we would use our math skills to figure that out, but we'll work on that later. All right, and the same thing applies down here. And so what I want you to do is go ahead. Oh, I know, I better just read. I'm like, what was my intention with this screen? I even looked it over pretty closely. Here's what we're going to do. We're going to do it again because now look, I'm in a different angle. So I want you guys to kind of get used to this. Sine is opposite over hypotenuse. So opposite is now 9. The hypotenuse, I'm going to call it x. And that's sine of 42 degrees, I might add. Now I'm going to do cosine of 42 degrees. Cosine cosine of 42 degrees is adjacent over the hypotenuse. Notice how this is adjacent. Hypotenuse is the one across from the right angle. So adjacent is 30. Hypotenuse, I don't know, so I'm putting x. Tangent of 42 degrees. Tangent is opposite over adjacent. Opposite is 4.5. Adjacent is 5. On last here, I'm just going to do tangent again. Tangent of 42 degrees is opposite, which is y, over adjacent, which is 90. All right? So that's basically what you're doing. That's how your setup works. We will also work on this in class. Have some activities to reinforce that, but there is your basics. And plenty of examples. On your calculator, you will be doing this. I just want you to know before we get to our calculators, this is what they did in the olden days. Way back in the day, you had like this chart. And good thing we don't have to do that. All right, so sine of L. That means I'm standing in this corner at angle L. And I am finding the sine of L. So I will put down L is equal to, and then I'm going to put down opposite over hypotenuse. So the opposite is 8. My hypotenuse is 17. No matter what, in any of these cases, this is going to be hypotenuse. That will not have to change, no matter what angle I'm working with. Okay, what does it say? Express each ratio as a fraction and as a decimal. So then you're going to take 8 divided by 17, and it's 0.47. And they don't say what to go to, so for now we're just going to do 2 decimal places. All right, cosine of L. Opposite, cosine is not opposite, I'm sorry. Adjacent over hypotenuse. So now the adjacent is this, which is 15, and the hypotenuse is 17. And now you go ahead and figure out what 15 over 17 is, and that is 0.88. And then we're going to do tangent of L. Tangent is opposite over adjacent. My opposite is 8. My adjacent is 15. Then we take 8 divided by 15, and we get 0.533. And I'm just going to put down 0.53. Okay, I wish I could move my board left and right, all my stuff here, so I could write more on this side. I might, yeah, okay, here we go. I'm going to go different color. And now let's look at sine of n. Now here's what happens. N is this angle over here. So guess what happens to this side? This side is no longer opposite. That side becomes your adjacent. And this side becomes your opposite because it's opposite over here. But notice the hypotenuse stays the same because the hypotenuse is always across from the right angle. So sine is opposite over hypotenuse. So my opposite is 15 and my hypotenuse is 17. Cosine is adjacent over hypotenuse. So the adjacent is 8 and the hypotenuse is 17. Tangent of n is going to be opposite over adjacent. So opposite over adjacent will be 15 over 8. And if you really want, you can put your decimals for that, but I'm not going to go do that. We're going to move on to example 2. Okay, now we're going to actually do a little figuring here. Let me skip ahead to make sure we've kind of got this worked out. I think I want to show you. The sine of A is opposite over hypotenuse. So here's my corner that's A. Opposite is 12. Hypotenuse is 20. So sine of A is 12 over 20. And we're just going to leave it. Just leave it. I don't actually even have any good directions here. Find the cosine of A. So cosine is adjacent over hypotenuse. Adjacent is 16. The hypotenuse is 20. And the tangent of A, opposite over adjacent. So I should have 12 over 16. Okay, now, Use a calculator to find the tangent of 56 degrees to the nearest 10,000th. Well, this sounds like fun. So let's go ahead and let me pull that up here. Oh, now I don't have my problem. What is it? Yeah. Use a calculator to find tangent of 56 to the nearest 10,000. Tangent of 56. All right, so you do need your calculator for this. Tangent of 56. When you do this, you're going to type in tangent. There are on the graphing calculator, let me point here with my pencil. There's my sine, there's my cosine, and my tangents buttons. All right? Tangent of 56, I press enter. 1.4825, blah, blah, blah. Okay, now, some of you may be like touching your calculators and going, I'm not getting that. So it's very important that you try. You need to go to this button right here. It's called the mode button. If you don't have a graphing calculator, you may have to ask me in class, but you probably have some kind of calculation button that does mode. If you look down here, I have normal, float, radian. We need to move radian over to degrees. So you just do your arrow button. Oops. And then go to degrees and then press enter, and it should stay there. All right, and then you can try again. So tangent of 56. Okay, so the nearest 10,000th. So this is 10th. 100th, 1,000th, 10,000th, and I have to look to the right. I see a 6. So it's going to be 1.4826. And I'm not going to write that down. You guys are all looking at it. 1.4826, because that 5 is going to be moved up to a 6 because of the rules of rounding. Okay, you can write that in your notes. Okay, my next question is use a calculator to find cosine of 89 degrees. So we're going to press cosine, one of the 3 buttons, of 89 degrees. Make sure your calculator is set on that mode of degree. All right, cosine of 89, and it's set to the nearest 10,000th again. So 0.017, this 4 is going to be pushed up because of the 5. So 0.0175, and go ahead and write that down. Okay, example 4. I'm going to let you use your calculator. I want to make sure you're touching them and figuring this out, and we will talk about it in class, see if you're on or off. So example 4 is yours to do. Example 5. A fitness trainer sets the incline on a treadmill to 7 degrees. The walking surface is 5 feet long. Approximately how many inches did the trainer raise the end of the treadmill from the floor? And they've drawn a nice picture for us. Okay, now here's where we have to choose. Are we going to use sine, cosine, or tangent? So I think this is my angle that I know. This is the opposite. And this is, of course, the hypotenuse. So which of those 3, sine, cosine, or tangent, involves opposite and hypotenuse? Well, sine. It's SOH, S-O-H. So I'm going to put sine of 7 degrees is equal to y over 5. And guess what I have to do? I have to solve for y. So I'm going to multiply both sides by 5. And watch out. I have 5 times the sine of 7 will be equal to y. So once again, I go to my calculator, and I'm going to show you this. I probably won't show you all my calculations here, but I think this one's important to see this. So 5 times the sine of 7 degrees, 5 sine 7 degrees. I don't have to press degree, I just press 7 because it's already set for degrees. All right. And I see 0.6093. Seems a little funny to me. 0.6093. Oh, 0.6093. All right, that's what that number is. Now, we've worked with feet, so this is 0.6093 feet. And it says how many inches, and it does have an approximation. So, if I want to figure out if I have 3 feet, what do I do to figure out how many inches that is? Oh yeah, 3 feet times 12 inches in a foot gives me 36. So I'm going to take 0.6093 times 12. Oh, please agree with me, board. All right, so take that times 12, and I'm getting 7.3116. So they do say approximate. I think 7.3 feet will, that doesn't even seem right either, does it? Oh, how many inches? That's right. I was like, feet, that doesn't make sense. Lost my train of thought. So we're going to have it in inches, and that makes more sense. 7.3 inches, because we take this times 12. All right? Example number 6. Similar problem, just a little different situation. The bottom of a handicap ramp is 15 feet from the entrance of a building. If the angle of the ramp is about 4.8 degrees, how high does the ramp rise off the ground to the nearest inch? And once again, they gave us this in feet. You know what I might do? I think I'm going to be sneaky and convert 15 feet times 12 inches in a foot, because they want the answer to be in inches. So this is 180 inches. So I'm being sneaky and doing this right away. All right. So now, I'm looking from the view of this angle. I have an adjacent, and what do they want us to find? How high does the ramp rise off the ground? So that's the X over there. So I have an adjacent, and I have an opposite, right? So which one am I going to use with adjacent and opposite? That will have to be tangent. So tangent of 4.8 degrees is equal to, it's TOA, opposite over adjacent. Sorry. So now I'm going to put that into my calculator. 15 times the tangent of 4.8 degrees. And I'm getting 1.259, which is like 1.26 or 1.3. I think I'll just put down 1.3. And what is this supposed to be? Inches. Okay. Example 7. Now this is what we call the inverse. Find the angle. They've given us the sides. Now we need to do a reverse thing somehow to find this angle. So I'm going to start with A. Okay. So if I'm working with A, I've got an opposite. By the way, this is a right triangle. I've got an opposite over an adjacent. So once again, I'm working with tangent. So tangent A is equal to 15 over 8. Okay, back to our calculators. We want to do like the reverse. So everybody, if you have your graphing calculators, and even if it's not a graphing calculator, you should still have your sine cosine buttons. Okay, so tangent of 15 over 8, if I remember correctly. We want to do, see how I have a tangent button, and I know it's not very clear, but I have what's called inverse tangent. Okay. That's right above your tangent button, or usually is. So to access that on mine, I press second to get the blue to come into there. And then I think it was 15 over 8, 15 over 8. So 15 divided by 8, 61.9. I think I will put 62 will be sufficient, I think, in this case, because we want the angle there. All right. So let me write that down. 62 degrees. Now obviously we can now go ahead and figure out what B is going to be. But I want to show you once again the trig in case for some reason I give you the other way, and there's another point I want to get at here. So if I start over here with angle B and I pretend that I don't know angle A, angle B gives me the opposite and the adjacent. So I work with tangent of B is equal to opposite, which is 8, adjacent is 15. But I don't know the angle, so I use that inverse button again. And so here I go. I'm not going to show you. But I do inverse tangent, and then 8 divided by 15. And I'm getting 28 on my calculator. So this angle is 28 degrees, which is kind of cool because what's 62 and 28? Well, 90 degrees. What else do I want to say about that? Which makes sense because there's 180 degrees in this triangle. So that's what happens when you take the tangent of one corner or one angle in your triangle and then take the tangent of another angle in your triangle. You'll find the appropriate measures for that. Okay, and then sometimes you don't have a problem like a picture like that with a triangle. Sometimes you have a situation like this. So in example 8, they have cosine of C is equal to 0.2493. So what I'm going to do is type in inverse cosine into my calculator of 0.2493. Okay, and I think what I'll do is I'll do a quick show of that again. So there is my line, inverse cosine of 0.2493, and there is a reason why we do 4 decimal places. As we get going through the rest of these chapters, if we don't do 4 decimal places, you will be amazed at how off you will be from somebody else who does 2 decimal places. So I've got 75.6, you can say 76 would be fine for me on that. So there you go. So 76, I want you to finish example 8. You should just be able to type those into your calculator and be good. All right, example, oh, there we are at the end. Talking about triangles, there's the Bermuda Triangle. I don't even know if that's accurate, but it gives you another thought of a different kind of triangle out there in the world.